Hey guys, what's up? Welcome back to the classroom. It's Mr. Low, and today we are gonna finish discussing on the chapter of angles, right? And we're gonna finish up the last part of this chapter that involve triangles. Well, we all know what triangles are. They're just shapes that involve. They have three sides, right? Okay, so there are three sides and three angles that are inside the triangle. And there are many types of triangles that we can draw and that we can see around us, right? So the first part of this chapter, we're going to talk about how to classify them, how to group them together, right? So here we are. We have two ways of this of classifying, either by their sides, right, or by their angles. All right. So let's look at the first part. By the way, we're at page 10 of the notes. So please flip to page 10 of the notes. All right. So here we go. So here way to classify number one is that by their sides. So when I say sides, means the length of their sides. Yeah. Okay. So we have three types over here. Number one, equilateral. Okay. The meaning of equilateral triangles means this triangle has three equal sides. That means the three sides all have the same length. And remember, we need to note down that these three sides have the same length by using this little line over here, okay, in the middle of the side. So three equal sides, equilateral. If I only have two equal sides, that means this side over here on the left and on the right are the same, but not the same as the base of the triangle. Okay, there are two equal sides. We call it an isosceles triangle. So there's a need to remember these names, equilateral and isosceles. Now, most of the triangles are not so lucky in the sense that not all the sides, you don't have sides that are the same, right? Most triangles don't have that, okay? This is called a scalene triangles, okay? So there are no equal sides for this kind, yeah? Usually, we don't need to remember this word scalene. We just need to know what is an equilateral, what is an isosceles, yeah? If there's no equal sides, then there's no need to mention about the name, usually, okay? Now, next, way to classify number two is by the type of angles. So let's recall we have learned about a few names for angles, right? Number one, we have acute, right? Acute. So recall, what is the definition of acute? Acute means anything between but not inclusive of 0 and 90 degrees, right? Okay, anything smaller than 90 degrees. So yeah, for acute triangles, all the angles inside, all the three angles that you see inside the triangles, they are all acute. Next one, a very special type of triangle is called the right angle. Notice that there's a 90-degree over here, right? So we have one right angle inside the triangle. This is what we call a right angle triangle. Okay, if there is an obtuse angle, like in this case over here, this angle over here, if it's obtuse, then we call it an obtuse triangle. So remember, what does obtuse mean? Which is an angle between bigger than 90 but smaller than 180 degrees. Yeah. Okay, so these are basically the types of triangles that we can have, right? Now, there's another property of triangle that I need you to remember. You're gonna use this for a very long time. Okay, if you need to, please pause the video and take it down by the side of your notes of page 10. Okay, now for all triangles, I don't care what is the size, I don't care what type it is. Okay, it can be isosceles, it can be equilateral, it can be an obtuse triangle. I don't care what type it is. I also don't care what's the size. All the three angles inside the triangle, they add up to 180 degrees. So I drew I sketched a little triangle here, angle A, B, and C, right? So for any triangle, A plus B plus C, the three angles add up is 180 degrees. Okay, if needed, please pause the video to take it down. This is very important. Okay, so let's look at especially two cases here. Equilateral triangle. So remember we said just now, equilateral triangles have all three sides the same, right? Which I actually noted down using lines over here. Okay, the red color lines here. Now, the rule of thumb is if I have two sides that are the same, the angles that these two sides touch, they are the same. Okay, what do I mean by that? We will see in isosceles triangle later. But for equilateral triangle, it's a very special case. All the three angles here, they are the same. So therefore, I write A equals to B equals to C. Now, when they are all three of them are the same, and they all add up to 180 degrees, we can immediately tell that each of them, A or B or C, they must all be 60 degrees. Yeah, 180 divided by 3. So for equilateral triangle, again, as I said, it doesn't matter what is the size. It can be a very small triangle. It can be a huge triangle, which we will see some examples later. Okay. I don't care what is the length of each side. The angles that are inside this equilateral triangle, it must be 60 degrees. Quite amazing. Okay, let's move on to isosceles triangle. Now, isosceles triangle, remember, two sides are the same, yeah? So when we have two sides the same, the two angles that are related to these two equal sides over here, which is B and C in this case, they are the same. Okay, so angle B equals to angle C. So if I have this guy here, A, what is the value? Well, if I know what is B and C, I can also calculate, right? Taking 180 degrees minus B minus C. So I can also write an extra information here. Angle A equals to 180 degrees minus, sorry, not A, my bad, is angle B minus angle B minus angle C. But we also know that B and C, they are equal. So I can also rewrite as 180 degrees minus 2 of B. Actually, also equals to 180 degrees minus 2 of C, since they are the same thing. All right, so yeah, just take note. Please have this down by the side of the notes. So for isosceles triangle, A is not equals to B, not equals to C, but B and C, they are equal. All right, okay, so let's take a look at a few real life examples of triangles, particularly equilateral triangle. Let's take a look here. Okay, we have road signs as the first example. Yeah. So if you have been traveling around right on public transport or in car, you might see some of these signs. Okay. Internationally they are all triangle shaped, right? Most of them, there are some of them that are circle, right? Some of them are triangles. Yeah. So these are equilateral triangles. This is an example. Secondly, have you seen this over here? This spot over here. Yep, you might recognize this as snooker or pool or billiards, whatever you call it, right? So they have this wooden triangle to help the players arrange the cue balls, the balls in a triangle shape to start the game. Yeah, this is an equilateral triangle as well. Okay, you can next time if you have a chance to play pool or play billiards, you can try to measure the sides of the triangles. They should all be the same. Next, you have, what is this? What is this over here? The pyramid, right? The Great Pyramids, yeah? Now, the Great Pyramids, they are each side of each face of the pyramid is a triangle, right? And they're all equilateral triangle. So that means from something as small as this this billiard triangle here to something huge like the pyramid, the side of a pyramid. I don't care, again, I don't care what is the size of the triangle. Each angle should be 60 degrees. Yeah, because they are equilateral triangle. Next, we look at, this is isosceles triangle. Yeah. So you have your roof, the roof of a house. Of course, these two sides must be the same, right? The slanted side, and which is different, probably different from the base of this triangle. You have cloth hangers. Yeah. The left side must be equals to the right side. If not, the shirt will not be when you hang a shirt there, right? It will not be straight. It will not be yeah. Right. Last one. I think most people's favorite snack. It is mine definitely, Tom Brown. All right. Some people say that this is this triangle here, the side is equilateral. Some say it's isosceles. I can't be sure. If you can grab hold of one, please go and measure and let us know whether this is an isosceles or equilateral. Definitely the two sides, the two slanted sides are the same, but is the base the same? I'm not too sure, right? You can go and check it out. All right, so let's come back to this. So we have learned about the different types of triangle, how to classify them. Okay, and we also learn very importantly that all three angles in a triangle add up to 180 degrees. It doesn't matter what is the size of the triangle. All right, so let's move on to the next part. Now, when I say all three angles in a triangle, okay, what I mean, there's another name for it, which is called interior angles. Okay, let's talk about this. Any interior angle, interior actually means inside. If you have heard of the word interior design for houses, right? Interior designers, they design the how does a home look like from the inside, not the outside. Yeah. So your furnitures, your paint, your decorations, all this, right? Those are interior design. So inside. Okay. So for example, yeah, the interior angles here are angle A, angle B, and angle C because they are inside the triangle. But how about angles outside the triangle? What do I mean by outside? So if I extend each line, if I extend each of the line like this, from like AF, BD, and CE in this case, I'm able to form usually an obtuse angle like this, X, Y, and Z. Now these three angles are outside of the triangle. Yeah, they're not inside. So we call them exterior angles. Okay, so the difference between interior and exterior. Exterior means outside, yeah? Okay. So just now we mentioned about interior design, design of the inside of a house or home, right? So what is the job that designs the outside of it? Well, architecture, yeah. Architecture is a job that designs the exterior, the outside, the appearance of a building. Usually a building, a huge building like an office tower, Yeah. So that's architecture, right? So what does it say here? An interior, well, angle, exterior angle of a triangle is equal to the sum of the two interior opposite angles. Okay, let's box this. Let's box this up. This is extremely important. Okay, this is extremely important. Please put a star here. Now, what does this mean? There's a lot of words here. Okay, an exterior angle, one exterior angle of a triangle is equal to sum means add up, right? So I add up the two interior opposite angles. All right. So there's a lot of words here. Let me give you an example of what it means. Let's come to this triangle again. Let's choose one of the exterior angle. All right. Let's choose angle Z, for instance. Okay. So if I look at angle Z here, okay, the statement says here this exterior angle is equal to the sum of the two interior opposite angles. Interior means inside and opposite. Okay, so which two angles are opposite interior angles to angle Z? Make a guess. They are angles A and B. Okay, so why are they opposite? Sort of like if I draw arrows like this, right? They're opposite. They're opposite to angle Z. So what does this statement mean? Okay, we can write down all the cases here. Angle Z equals to A plus B in this case. All right. So angle Z equals to A plus B. Can we do so for Y? Can we do so for angle Y? Which two angles are opposite to angle Y, sorry. Well, if you do what I did just now, something like this, you realize that it's angles A and C. So Y equals to A plus C. So this is a special property of triangles. Okay, it's something that you also need to remember and it will be very, very useful. Finally, we do it for X. what are the opposite interior angles of x? B and C. Yeah. All right. So x equals to B plus C. So this is what it means. All right. Please have them down in your notes. Pause the video to take them down if you need to. Okay. Here we have an example over here. In the figure below, ABC is a quadrilateral. What does quadrilateral mean? Actually, it means four-sided figures. We don't need to know yet, but we just take a look. We're looking at A, B, C, D. This four-sided shape here. Okay. It's not a square. It's not a rectangle. I don't know. We can't tell, right? Okay. And VCE and BAG are straight lines. BCE, BAG, they are straight lines. Okay. So in this case, there's one thing to learn from this example here. The question specifically say that BAG and BCE, they are straight lines, right? If the question did not mention specifically that they are straight lines, do not assume that they are straight line. Do not think that they are straight lines. For example, CDF. The question did not say that CDF is a straight line. Do not think that it is a straight line. Okay, so please read the question carefully. Yeah. Okay, so move on to the question. All right, which marked angles are interior angles of this four-sided A, B, C, D, E? So they are asking for interior angles. Okay, or the question is simply asking which angles are inside A, B, C, D. So let's go to this, right? A, B, C, D. Which two are inside? Well, C and A, right? Because they are inside this four-sided shape. Yeah, this four-sided shape. Okay, so we can write down the answer A and C. A and C. Next one, which marked angles are exterior angle? Exterior, remember, means outside. Okay, exterior of ABCD. So that means they're outside ABCD, but they must be related, yeah? Okay, so what do we have? Okay, remember that exterior angles is not simply just any angles that are outside, but it must be an angle that is formed by drawing an extension line. So for instance, this case here we have EC. EC is an extension line of the line BC. Yeah. So Q is one of them. Is there another extension line that we have drawn that is inside this diagram? Yeah. GA, isn't it? AG. Yeah. AG is the extension of the line BA. So therefore, S is another exterior angle. P is not an exterior angle because it is not formed with any extension line. And just now, as I said over here, the line CDF is not a straight line, because the question did not say. So R is not an extension. It's not an exterior angle. So we only have two exterior angles here, Q and S. So let's write it down, Q and S. All right. Now, next one. If angle A is 115 degrees, where is my angle A? Okay, I need to erase a lot of things. Where is my angle A? Angle A is over here. If my angle A is 115 degrees, what is angle S? Which is this guy. What is this? Well, it's quite simple. We do know that BAG is a straight line. So immediately we can think of supplementary angles. Yeah. So angle S equals to 180 degrees minus angle A. And remember, what should we always do? We must always have the reasons. Yeah. So this one is a adjacent. You can write supplementary angles. You can also write adjacent angles on a straight line. All right, up to you. So from there we know that angle S is 180 minus 115, and that gives us 65 degrees. So what does this example tell us? It tells us that if I have an interior angle and an exterior angle that's adjacent to each other, in this case, A and S, or I can even talk about C and Q. They add up to 180 degrees because, well, they add up to a straight line, right? Okay, if Q is 100 degrees, find angle C. Yep, exactly as we were saying. Okay, so we use the same thought process. Angle C equals to 180 degrees minus angle Q. Again, same reason, adjacent angles on a straight line. Yeah, adjacent angles on a straight line. And from there, we know that angle C equals to 180 degrees minus 100. And that gives us 80 degrees. And we are done. Okay, so this interior angle and exterior angle thing also works for triangles. Yeah, so you can see very clearly from this case over here, X and A, they add up to 180, B and Y add up to 180, C and Z add up to 180. Okay, so this is something that just bear in mind. Okay, so let's move on. Okay, example 10. This will be the last example that we will discuss for this video. You can try the subsequent ones on your own. Okay, so let's see here. This diagram here is made up of three triangles over here. We have triangle ABC. Let's try to mark it down. We have triangle ABC. We have triangle CDE, and lastly EFG. Yeah, and so we recall that all the angles, all the interior angles in a triangle add up to 180. Right. So before I even start the question, I already have some information here and there. Okay, let's take a look. Um, in this question, it says that okay, ACB is 107, CDE is 32. Find with your reasons stated. Of course, even if the question did not ask you, you should always state your reason for this kind of angle questions. State your reasons. The sum of angle A and B. Sum. We're looking at sum of angles A and B. So they're asking you, angle A plus angle B, what is the value? So how do we do that? Well, we can look at the green triangle on its own, ABC. And we do know that they add up to 180 degrees. So immediately, why not? Let me just do it here, right? You can copy the answer at the bottom after the question. Okay, so for part A, they ask what is angle A plus angle B. We do know that angle A plus angle B plus 107 degrees, pardon me, is 180, right? They sum up to 180 degrees. Of course, we must quote our reason. Sorry, what is the reason here that we should quote? Here, this is the one. Angle sum of triangle. Angle sum of triangle. So let's do it over here. The reason is angle sum of triangle. Yeah, angle sum of triangle, right? So they're asking for what is A plus B. So therefore we know that angle A plus angle B is 180 minus 107 is 73 degrees. And we are done for part A. Yeah. Angle sum of triangle. So that is the property or the reason that we need to quote. Okay, moving on. What is the sum of F and G? Let's take a look. Where is F and G? Okay, so F and G are inside this red color triangle here. Okay, so in order to find out, let me erase certain stuff. Okay, so in order to find out what is the sum of F and G, you realize that, we should be doing the same thing as part A. Yeah, so we do know that angle F plus angle G plus this angle here, FEG, they add up to 180. But we don't know what is FEG. So how? Is that the end? No? Game over? Not really. if you look carefully here, you can see that angle FEG is the same as angle CED. Why is that so? Why are they equal? Because of vertically opposite angles, right? Because of vertical opposite angles, these two are equal. Okay, so if I can somehow find, CED, then I can do my question. But I also don't know what is CED. Is that the end? Of course not. We move on back to this blue color triangle, like right, this blue color triangle here. We see the angle CED, right, and this 32 degrees, as well as this green one here, ECD, they add up to 180. So if I can somehow find out what is this ECD, then I can find my answer. So what is it? Well, if we've been following the line of thought, we realize that these are equal also because of vertically opposite angles. Yeah. So actually we are done. We know that this green angle here is 107. We know that this angle here is 32. Immediately we can find the red color one, CED. Am I right to say that? Okay, there are a lot of steps here, so let's try to follow carefully. Okay, now let's do it step by step. So let's begin with angle ECD then. Okay, so angle ECD equals to 107 degrees. And how do we know that? Because of vertically opposite angles. Yeah, vertically opposite angles. Okay, so with my information of ECD, I can immediately find CED. So angle CED using the blue color triangle equals to 180 degrees minus 32 degrees minus the 107 that we just discovered. Yeah, and we need to quote the reason, which is angle sum of triangle. Okay, angle sum of triangle. And what value is this? 180 minus 107 is is 73. 73 minus 32 is 41. 41 degrees. Okay. So we have found that the red color angle here is 41 degrees. And immediately we know that angle FEG equals to angle CED equals to 41 degrees. And how do we know that? Again, it's vertically opposite angles. Vertically opposite angles, yeah? Okay. So 3 steps already. That's quite a lot, okay? Now last one, we need to find what is F plus G. So again, we are looking at the red color triangle over here. So angle F plus angle G plus our FEG, which is 41 degrees, equals to 180 degrees. Okay, and we need to quote the reason, angle sum of triangle. Yeah, okay. Okay, and we are finally done. We are interested in finding F plus G. Yeah, so angle F plus angle G equals to 180 minus 41, and that gives us 139 degrees. And we're done. Okay, so in this question, we can see that, we are using knowledge from the previous part, which is vertically opposite angles. Yeah. So just now I mentioned that if the question did not state, you cannot assume that these lines are straight lines, because when I do vertically opposite angles, I am indeed assuming that this line here, for example, and this line, they are straight lines. Okay. If the question did not state and you suspect that they are not straight lines, you can always raise your hand to ask to clarify with the examiner whether these lines are straight lines, right? Otherwise, my suggestion is try not to assume, especially if the diagram is drawn such that it doesn't look like a straight line. Like in this case, right, CDF, it doesn't really look like a straight line. So do not assume. Yeah, you can always clarify by asking and raising your hand. All right, so for this last example, let's discuss in another video. But you can try yourself first. Okay, you can try on your own first before attempting the homework question. Yeah. So yeah, that's it. All right. I hope you had fun learning this part. I think this is a quite interesting chapter. Okay, we will see more of this in upper sec. All right. So I'll see you soon. Take care.